Hi, everybody. So in this lesson, we're going to be continuing our work from last week. We're going to be continuing with two-dimensional geometry. Last week, we focused on kind of our basic shapes, so rectangles, squares, triangles, circles. This week, we're going to be covering the rest of the two-dimensional shapes that might show up on the GED test. So our goal for this lesson is that we're going to get some practice with computing perimeter of a polygon, given a geometric formula, computing the area of a polygon, determining side lengths of a figure when given perimeter or area, and then computing perimeter and area of 2D composite geometric figures, including circles, using formulas as needed. So as you watch this lesson, probably be a good idea to have your pencil and paper, maybe any notes or work that you have from last week, as well as a calculator and a copy of the GED math formula sheet if you have it. All right, so we're going to start here with a little warm-up problem. It says a total of 64 feet of fence is required to enclose a square vegetable garden. What is the area of the garden? So what I'd like you to do is I'd like you to pause the video right now and try this question on your own, thinking about problems that we worked on last week. This is really similar to a couple of those problems. And then when you're ready, you can press play again and I will walk you through the problem. So the problem tells us the type of shape we're dealing with here. We're talking about a square. So a square is a four-sided shape with four right angles. And what's special about a square is that it has four equal sides. We got to keep that in mind, four equal sides. The other piece of information we have is that a total of 64 feet of fence is required to enclose this garden. So that means all the way around the garden is 64 feet. That's the perimeter of the garden. So the total distance around this garden, the perimeter, is 64 feet. So we're told the type of shape and we're told the perimeter. And then ultimately our goal is to figure out what the area is. And that's what the question's asking us to do. So ultimately our final answer will be the area of this garden. So we said a square is a four-sided shape with four equal sides. Now when I think about calculating the area of a square, I know that the area of a square or a rectangle is the length times the width. Now that's something we talked about last week. It's also on your GED math formula sheet. So the area of a rectangle or square is the length times the width. So for this square, I need to know the length and the width to calculate the area. Now, what's nice about a square is those two things, the length and the width are going to be the same thing because all the sides are the same. So really what I need to do is I need to figure out the length of one of the sides of the square. How can I do that? Well, I have the total distance around the square, 64 feet. If I want to cut that up into four equal parts, into the four equal sides, I can divide it. So 64 feet divided by four equal sides will give me an answer of 16 feet per side. So 16 feet for each side of this square. So now I have the information I need to go ahead and calculate the area. My length and my width for this square are both 16 feet. So I'm going to do 16 feet times 16. So 16 feet times 16 feet. And that's going to give me a result of 250 256 square feet. So the area of this garden is 256 square feet. And that is our final answer. All right, so next thing we're going to talk about here are polygons. So I used that word at the beginning of the lesson here. A polygon is a closed plane figure with straight sides. This is one of the words on our vocabulary list from last week and this week. And if you have studied your vocabulary list, or if you listened to the lesson from last week, you should remember that a plane figure just means a flat shape. So a polygon is a flat shape that has straight sides and it's closed. Up in the top right corner of the screen here, I have some examples of shapes that don't meet that definition. So things that are not polygons. We've got this cloud shape. This isn't a polygon because it has all these curved edges. We just got this kind of random looking shape that I drew. And again, it's not a polygon because it's got curved edges. A circle is not a polygon because it's curved, right? It doesn't have all straight sides. And then this fourth shape here almost meets the definition, but not quite because it's open. There's a little entryway into the shape here. So this is not a polygon because it's an open shape, not a closed shape. And then towards the bottom of the screen here, I've got on the left-hand side some examples of irregular polygons. And then on the right-hand side, examples of regular polygons. So regular polygons are polygons with equal sides. So when you're looking at a shape, a flat shape with equal sides, all of the sides are the same. Sometimes you might see that called a regular polygon. And then if it doesn't have equal sides, it's irregular. So a rectangle is an example of a shape that is an irregular polygon because it has four sides, but the four sides aren't all the same. So just imagine that these sides are straight that I just drew here. So a rectangle is another example of an irregular polygon. Now let's look at these regular polygons. So the first one we've got here, it's a four-sided shape where all four sides are equal. So that would be a square, like we just worked on in the warm-up problem. And then next to the square, my touchpad's being a little tricky here. Next to the square is a triangle that I drew where all three sides of the triangle are the same. So you can have triangles with sides of different lengths. It's perfectly okay, perfectly common, but this triangle just happens to have three equal sides. And then below this square in this triangle, we've got a couple more examples of regular polygons. The one on the bottom left here is a five-sided shape where each side is the same. And the name for a five-sided polygon is a pentagon. So you might see that word pop up occasionally in different problems. It just means a five-sided shape. So if you have a regular pentagon, that is a five-sided shape where all sides are the same. And then next to that, we've got a six-sided shape where each side is the same, and that's called a hexagon. And there are plenty more of these shapes. Different sides have different names, different numbers of sides have different names. So that's just a couple of examples for you. So let's get a little practice here with calculating perimeter of these regular polygons. So on this page, we've got a couple of regular polygons. Now, a lot of times with geometry problems, I tell you not to assume the measurements of sides. You want to be very careful about making assumptions just by looking at the pictures. But we're going to see with these two examples that we can make some assumptions. So let's look at the purple one first. Let's say I'm taking the test and it says something like, calculate the perimeter of the shape shown below. So let's say it says that. Since they only give us the measurement of one side here, so the top side, they don't label any of the other sides, but they're asking us to calculate the perimeter. We can go ahead and we can assume that each of these sides are intended to be the same. So we can make that assumption here. This shape has 8 sides. So the name for an 8-sided polygon would be an octagon. That's actually the shape that stop signs are. So stop signs are regular octagons. They have 8 equal sides. So since I'm asked to find the perimeter of this regular octagon, I know it's got 8 equal sides, and each side is 7.25 inches. I could either add up all of those sides, or I could take a little shortcut just by multiplying. So 7.25 inches times 8 equal sides will give me a total length around this shape of, just double check my math here, make sure I write it up correctly for you, 58 inches. So the perimeter of this octagon is 58 inches. Okay, now onto this yellow shape here. So again, if I have a problem where it says calculate the perimeter of the shape below, I look at this shape and I see there's only one side labeled, but I'm being asked to calculate the perimeter. I can go ahead and I can assume that each of these sides are equal. And there's a total of 5 sides. 1, 2, 3, 4, 5. And again, what's the name of a 5-sided shape like this? The name for it is a pentagon. All right, so each side here is 4 centimeters, and we've got a total of 5 sides. So you could either add each of those sides up. You could say 4 plus 4 plus 4 plus 4 plus 4. Or you can take a little shortcut and just multiply. So 4 centimeters times 5 sides gives us 20 centimeters. So the perimeter of this shape is 20 centimeters. All right, so on the next screen here, we're going to get some practice with calculating area of the shapes that we did not talk about last week that are on our formula sheet. So last week, we worked with squares, area of squares, area of rectangles, areas of triangles, and areas of circles. So we're not going to forget about those. We are going to keep using those shapes, keep practicing with them. You're definitely going to be working more with those formulas later on. But on this slide, we're going to see a couple of examples of these other 2 shapes that we haven't worked with yet. So parallelograms and trapezoids. So the first shape I have here on the left-hand side is a parallelogram. So a parallelogram is a 4-sided shape where opposite sides are parallel to each other. So it has 2 pairs of parallel sides. Make sure I spell parallelogram correctly while I talk at the same time. So parallelogram. And you can see here, right, that the left side and the right side are pointing in the same direction. And then also the top and the bottom are pointing in the same direction. So 4 sides, and you've got 2 pairs of parallel sides. So I look at this, let's say the question just says, calculate the area of the shape below. I would look at this shape and I would need to say to myself, this is a parallelogram because it's got 4 sides and 2 pairs of parallel sides. So then I go down, I look at my formula sheet if I need a little reminder, because you get to use your formula sheet on the test. So I look at my formula sheet and I see area of a parallelogram is equal to the base times the height. So it says A equals BH, which means area equals base times height. Remember, the formula is just a little like shorthand set of directions for how to do the calculation. So area equals base times height. So in order to calculate the area, I need to identify the measurement of the base for this parallelogram and also the height. So in general, with any shape where you're talking about base and height, you're looking for 2 lines that cross each other at a right angle. Oftentimes the base will be the bottom of the shape, but not always. It could be rotated around or tilted a little bit. So you're looking for 2 lines that cross each other at right angles. So when I look at this parallelogram, I see that the bottom here, the 15 inches, connects with this dotted line here at a right angle. That's what this little symbol means. It's a nice square corner that they're making with each other. So that's how I know I've found the base and the height. The base goes along the bottom of the shape here, and then the height is a straight line going from the bottom up to the top, right? It's measuring the height of the shape. So the base is going to be 15 inches, and the height is 9 inches. Now it's very important that you find the correct measurement for the height. Sometimes people are tempted to just use anything that's slightly vertical on the shape. Like you might be tempted to take that measurement of 10 inches from the side here. But when I look at the 10 inches, I know that this is not the height because it's kind of going at a diagonal from the base of the shape, right? And we don't want something that's all diagonal and wonky. We want a nice straight line going from the bottom up to the top of the shape to measure the height. So 15 inches times 9 inches will give us an area of 135 square inches for this parallelogram. All right, let's move on to the second shape we've got here. So this shape is a trapezoid. So a trapezoid is a 4-sided shape with only 1 pair of parallel sides. So that's what's special about trapezoids. They're 4-sided and they have just 1 pair of parallel sides. But the parallelogram has 2 pairs of parallel sides. Everything's nice and parallel to each other, but with a trapezoid, there's only 1 pair of parallel sides. With this trapezoid, you can see it's this top and bottom sides here that are pointing in the same direction. They're parallel to each other, but the left and right sides are not pointing in the same direction. So I'm being asked to calculate the area of a trapezoid. On the test, the question might be something like, calculate the area of the shape below. So I would look at the picture and I would say, aha, that's a trapezoid because it's got 4 sides and only 1 pair of parallel sides. So I go to my formula sheet and I find the formula for area of a trapezoid. This one's got a little bit more to it. So it says A equals 1/2 times the height times the sum of the two bases. So B1 plus B2. That's just telling us there are two bases that we need to look for. So in order to calculate the area of this trapezoid, we're going to need to determine the height. And we're also going to need to determine the measurements of the two bases. I'm going to go ahead and bring down that 1/2 because that'll stay the same. Leave an empty space there for the height and for the two bases. So first thing I'm going to do, I'm going to look for the two bases. Now on a trapezoid, the two bases are, oftentimes it's going to be the top and the bottom, but it's whatever sides are parallel to each other. Those are the two bases. So for this trapezoid, we've got these two parallel sides. One of them is 31 feet. And then the other one is 13 feet. So I'm going to put those down for my two bases. And then the height, right, is this straight line going from the top to the bottom, or the bottom to the top, depending on how you want to look at it. Straight line makes this nice right angle with the bases, this nice square corner. So that height is 15 feet. The shape is 15 feet tall. Okay, so I got all my information filled in here. Now, just a matter of doing the calculation. So since this calculation has a little bit more to it, we want to be careful here, especially if we're doing this by hand. So we've got multiplication. The multiplication right here, right? 1/2 times 15 times, and then we've got addition inside parentheses here. So I'm going to need to think about my order of operations. The order of operations is PEMDAS, or please excuse my dear Aunt Sally. You might remember that. So P-E-M, M and D, and then A and S. So this kind of gives us the 4 levels or the 4 steps in the order of operations. The first one is parentheses. So that means any calculation that is sitting inside of parentheses, we want to do that first. So for this problem, for this calculation, that means we want to do this addition that's sitting inside the parentheses first. So I'm going to just bring everything else down, keep it all the same. 1/2 times 15. And then I'm going to actually do that addition. So 31 plus 13 is equal to 44. Okay, so now I've taken care of the addition inside of the parentheses. And now all I have left is multiplication. So 1/2 times 15 times 44. It's all multiplication. Now with multiplication, the order doesn't really matter, right? Like 2 times 5 means the same thing as 5 times 2. You'll get the same answer. So with multiplication, it's up to you what order you want to do things in. Sometimes like one order might be a little bit easier than another order. What I'm going to do here is I'm going to multiply the 15 and the 44 first. So just bring down that 1/2 again. I'll do 15 times 44, which gives me 660. And now all I have left to do is 1/2 times 660. Now, when you're multiplying a number by a fraction, one way you can think of it is using the word of. So when we say 1/2 times 660, that means the same thing as 1/2 of 660. That might be a little bit easier to think about. So if you ask yourself, what's 1/2 of 660? Well, It is 330. Another way you can calculate that is by dividing by 2. So if you do 660 divided by 2, that'll give you the same answer as multiplying by a half. So our final answer here, after we do all that multiplication and addition, is our final answer is 330 square feet for the area. 330 square feet. I had some questions earlier this week with folks who were attending the lesson about like what happens if you get the units wrong. So like what happens if you forget to say square feet and you just have feet? Well, in terms of the GED test, it's probably not actually too important because most of the time you're going to be working on multiple choice questions, so it's going to be written out for you. That's why the weekly assignments that I've been posting on Google Classroom, they're mainly multiple choice questions where the correct units are already included for you. However, units are really the thing that gives meaning to the numbers that you have in front of you, right? So I could say like 330, but 330 doesn't really mean that much unless I know like 330 what? Right? Am I talking about 330 miles? Am I talking about 330 kittens? Am I talking about 330 square feet? What am I talking about here? So the units are really the meaning behind the numbers. So when I'm working on problems, I like to make sure that I'm thinking about the units and that I'm making sure that I write them down, especially in my final answer. On the screen here, I'm not writing down every single unit for every single number just because with my technology setup here, it takes me a little longer to write things out on the screen. But certainly if I was writing this out for myself on a piece of paper, I would be including those units and really thinking about them as I go. So the answer to the question of what happens if I get the units wrong is, for the most part, it's probably going to be okay because the GED is set up where it's already written out for you. But if your goal is to really understand the work that you're doing and to be a careful thinker, then I think making sure you practice those units and really paying attention to them is important. And if you go on to take some more math classes like at college, then you might have some non-multiple choice questions that you're working on where it might be important to make sure you include the correct units in your final answer. Okay, so let's move on here. The last kind of category of shapes that we're going to talk about this week are composite or compound two-dimensional figures. So flat shapes that are compound. A compound figure or a compound shape is a shape that can be broken down into simpler shapes. So a shape that can be broken down into some of those shapes that are listed on our formula sheet. And I've just got a few examples of compound two-dimensional shapes up on the screen here. So this first one, this one on the left-hand side here, if you ignore the dotted line, right, you might look at that shape and be like, oh, well, it's this kind of rounded thing. Maybe it looks like a part of a basketball court, maybe. Could be like a strangely shaped like house or something that's tilted on its side. Who knows? We don't have a special name for this shape. But if I imagine this dotted line going down here, then I see this shape that originally I didn't have a name for. I can break it up into two simpler shapes that I do have a name for. I can break it up into a rectangle and a semicircle or a half circle. So this compound figure can be broken up into a rectangle and a semicircle or a half circle. And those are things that, you know, if we were asked to find area, we have formulas for those shapes. So we can calculate formulas for area of the shapes, whereas, you know, we don't have a formula for a basketball court looking thing. right? We wouldn't really know how to do that. So we got to break it down into simpler parts. Now the one in the middle here, you might look at it and say, oh, it looks like steps, or maybe it looks kind of like a kid's drawing of a factory, something like that. But if we draw a dotted line across it, we can split it up into two shapes that we do have names for. When we split it up, it becomes two rectangles. Now I chose to split it up with this horizontal dotted line here. But you could have chosen instead to split it up with a vertical line going down like this. It wouldn't really change things too much. You would still have two rectangles that are stuck to each other. And then this third example that I have, right, we do actually have a name for this shape. We would say it's an arrow. But if you have a problem on the test that's asking you to find the area of this shape, we don't have a formula for area of an arrow, right? We don't have a way to deal with that. So the way that we would deal with it is we would break it down into its simpler shapes. So I drew this dotted line here that shows that this arrow is actually a rectangle stuck to a triangle, right? And we have formulas for area of a rectangle and area of a triangle. So we could go ahead and calculate those areas without too much trouble. So on the next page here, we're going to get some practice calculating perimeter and area of compound figures. So I usually say compound figures. You might see it written as composite figures. It means the same thing. Compound or composite just means something made up of simpler shapes. All right, so we've got this compound figure on the screen here. And we're going to calculate the perimeter and the area of this shape. So we're going to start with perimeter first. Now, when we're asked to find perimeter of something, we got to remember what perimeter means, right? It means the total distance around the outside of a shape. So for shapes with straight sides, so polygons, what perimeter really means is just adding up all the sides to find the total distance around the edge. So for this shape, to find the perimeter, I'm going to add up all the sides. But I try to do that, I'm going to run into a little issue first because I don't know yet what the measurements are for these sides. I don't have those written down yet. Now, you might look at them and you might be tempted. You might be tempted to say, well, oh, this side here looks like it's about the same as this side here, and this one's 4 feet, so I'm going to assume that this one's also 4 feet. Remember what I said a few minutes ago about assuming those kinds of things. In general, if you're given a bunch of information about a shape, in general, you're going to want to use that information that you're given to calculate missing sides instead of just assuming what they are based on what they look like. So the first thing I need to do before I can calculate the perimeter of this shape, so that's the second thing I'm going to do. The first thing I'm going to have to do is I'm going to have to figure out what those missing sides are. So that's going to be my first step for finding the perimeter. So find or determine or calculate, whatever word you want to use, find the missing sides. Find those missing measurements. And again, we're not going to do it just by taking a look at it and estimating. There are some situations where that might be appropriate, but in general, that's not going to be the case for these types of problems. We want to do some calculations using information we're given to find the exact measurement. So we're going to find the missing sides. So let's start with this vertical side here. This vertical side. Now, usually what I want to do to find missing side lengths is I want to look at other sides on the shape that are pointing in the same direction. So for this vertical side, I'm going to use these other two vertical sides to help me figure out the measurement. So I've got this side here that's 9 feet, and I've got this side here that's 5 feet. So what that tells me that this shape from the bottom up to the top is 9 feet tall. And then, right, this height of this like bottom rectangular part is 5 feet. So that's gonna be true all the way across the shape. So from here up to here is 5 feet. So if the total height from bottom up to the top is 9 feet, and then the part from here to here is 5 feet, that means this portion right here is going to be 4 feet. Right, 9 feet minus 5 feet, the difference between those two is 4 feet. So that vertical missing side was 4 feet. So if you had assumed it was 4 feet because it looked similar to this other side that's 4 feet, you would have been correct, but that's not always the case. So you want to be careful. All right, now let's take a look at this other missing side, this horizontal side right here. And to do that, to figure out what that side length is, we're going to look at the other two horizontal measurements that we have. So this 4 feet up top and this 11 feet at the bottom. So the 11 feet is telling us that all the way across this shape, from one side all the way over to the other, is 11 feet. And then we know that this portion right here, from here to here, is 4 feet. So if all the way across is 11 and then this part is 4, well, the remaining part here has to be 7, right? 11 feet, take away 4 feet is going to give us 7 feet for this missing horizontal side. Okay, so now I found the missing sides. I took care of that first step. Now I can go ahead and calculate the perimeter. So in this case, calculating the perimeter, right, since they're all straight sides, I'm going to go ahead and just add up all those sides. So I'll start at the top and I'll go around clockwise. It'll be 4 feet plus 4 feet plus 7 feet plus 5 feet. Get my plus sign there. Plus 11 feet plus 9 feet. And when you add all those up, you get a total of, double check here, 4 plus 4 plus 7 plus 5 plus 11 plus 9 is 40. So a total of 40 feet for the perimeter. Okay, so we're done with perimeter. We got that taken care of. Now we're on to area. So as I kind of started talking about in the last slide, when you are dealing with area of a compound shape, since we don't have formulas for those compound shapes, what we need to do is break it down into simpler shapes that we do have formulas for the area. So for this shape, taking a look at it, and to me, looks like I could split it up into 2 rectangles or maybe a square and a rectangle. So you could, if you split it up here, what you're gonna have is a long rectangle at the bottom here, and then you've got a square sitting on top. You could also, a different way to split it up would be to think of a dotted line here. Then you would have sort of a left-hand rectangle that's like sitting up, and then you have a right-hand rectangle that's laying on its side. So With this particular shape, you could split it up in two different ways. Either way is correct. Either way will get you to the correct answer. I'm going to leave it like this. So I'm going to have this long rectangle at the bottom and then a square sitting up top. So the first thing we did here, before we started actually thinking about calculating area, was we split the compound shape up into simpler shapes. So first step when calculating area of a compound figure is to split it up into simpler shapes. And they're going to need to be shapes that you have the formula for calculating area for. So split into simpler shapes. Shapes that you have listed on your formula sheet, or shapes that you've worked with before. Okay, so we split it up. Now, next thing we're gonna do, we're gonna move on to actually calculating the areas. So since we split this up into a square and a rectangle, to calculate the area, we're gonna calculate the area of the square, calculate the area of the rectangle, and then to find the total area, we'll add those two parts together at the end. We'll add those two individual areas together. So we'll start with the square, area of a square. Now, if you look at your formula sheet, the area that they list for square, it says A equals S to the power of 2. That S is standing for side length. And it's another way of thinking about area of a square, since for a square, all sides are the same. When I'm thinking about area of a square, I like to use the same formula as area of a rectangle. Squares are just a special type of rectangle, and I know that rectangles are length times width. That's really my most basic area formula. So area of a square or a rectangle is the length times the width. Now for a square, that just happens to be the same measurement. So for this square, when I take a look at it, I can see that each side is 4 feet long. So the length times the width is going to be 4 feet times 4 feet. And that'll give me a total area for that square of 16 square feet. So the area of the square is 16 square feet. Okay, now on to the rectangle. I'm not going to write out the whole word because it's long, but we're going to do the rectangle next. So for a rectangle, again, same formula, area equals length times width. So for this rectangle, it is 11 feet long. When I look at my rectangle at the bottom here, I want to make sure I'm getting the whole length here. So in this case, the way that I split the shape up, I would ignore this 7, because the 7 only gets me this portion of the rectangle. I want the whole length of the rectangle. So 11 feet long by 5 feet wide. And 11 times 5 gives us 55 square feet. And then to find the overall total area for this compound figure, we would just go ahead and add up those components, add up those two shapes. So the total area is going to be 16 square feet plus 55 square feet. and that's 71 square feet. Now, if you attended one of the lessons earlier in the week, I think when we did this together, we did it the other way. So where we split the shape up into a rectangle on the left side and then a rectangle on the right side. So we split it up along here. So when we were in the midst of doing the area calculations, our numbers looked a little different, but we still arrived at the same answer. So oftentimes there will be a couple ways you can split a shape up that work fine. Either way, you should arrive at the same total area. All right, let's look at the next example here. So again, we are going to calculate the perimeter and area of this compound figure. Start with perimeter. So perimeter means adding up all the sides. When I take a look at this compound figure, I can see that all of the sides are filled in. So with the last figure, we had to start out by finding the missing side measurements. We didn't have all the sides, so we had to start out by doing that. With this one, we don't need to do that because they're all filled in. So I'm just gonna get straight to it. I'm gonna add up all of the sides. So 5 feet plus 7 feet plus 6 feet plus 10 feet plus 10 feet. And when I add those up, I get a total of 38 feet. All right, and that's my perimeter, all done. So now on to area. I'm gonna separate these so we got some clear space to work on our area. So same thing that we did last time for area of a compound figure. First thing we're gonna need to do is we're gonna need to split this shape up into simpler shapes. So when I take a look at it, I see, well, I could split it up along this line here, and that'll give me a triangle at the top and a rectangle at the bottom. You could also, a different way of splitting this shape up would be to draw a line down this way. If you did that instead, you would have a trapezoid on the left side here, and then a rectangle on the right side. So that would be a different way to split it up. A lot of times people don't like dealing with trapezoids as much, so we'll do it with the triangle instead of the trapezoid. All right, so we got this triangle up top and this rectangle at the bottom. So to calculate area, we're going to start off by calculating those individual areas for each shape first. So the triangle, start with that. I'm not going to write out the whole word because I'm slow at writing here. So triangle area. If we look on our formula sheet, we'll see that for a triangle, the area is equal to a half times the base times the height. Okay, so let's start trying to fill in that information. A half times the base times the height. So let's go over and look at the triangle. Now, remember what we talked about on the previous slide about how really on any shape, the base and the height always form a right angle with each other. So always a nice square corner. And oftentimes the base will actually be the bottom of the shape. So for this triangle, when we look at the base or the bottom, that's right here. And then a straight line going from the base up to the top of the shape, making a nice right angle, would be this side right here. And we don't actually know the measurements of those two sides. We don't know the base. We don't yet know the base of this triangle or the height of this triangle. We know the height of the whole shape is 10 feet, but we don't know the height of the triangle. So we're actually gonna have to fill in that missing information to do a little calculating. So let's start with the height of the triangle. We know that the length of this whole side here, so from the bottom all the way to the top of the compound figure, is 10 feet. And then we know that the height of this rectangle at the bottom is 6 feet. So from the bottom up to here is 6 feet. So if the whole thing is 10 feet, and then from the bottom up to that point is 6 feet, that means this triangle has got to be how tall? Well, it's got to be 4 feet tall to give us a total of 10. So the height of this triangle is 4 feet. Now, what about the base? Well, we know that from here to here on our compound figure is 10 feet. So it's kind of the total distance from the left side to the right side. And then we know that this part here is 7 feet. So what's this missing portion going to be? Well, if the total is 10 and we know that this portion is 7, the remaining part has to be 3 feet. So 10 feet, take away 7 feet will give us 3 feet. So for this triangle, the base measures 3 feet. The base measures 3 feet. And the height measures 4 feet. So the area of the triangle will be a half of 3 times 4. So 3 times 4 is 12. And then half of that, half times 12, or 12 divided by 2, is 6. So this triangle has an area of 6 square feet. All right, so that's the triangle. Let's do the rectangle next. So we know for a rectangle, the area is length times width. By the way, length times width is really just another way of saying base times height. On the GED math formula sheet, they write A equals length times width, or L times W. But if you're looking at a different source, so if you've got a different textbook or you're watching like another video, you might see it written as base times height. I kind of wish they would write it as base times height just because all of the other formulas use base times height. And I think that shows how all of these formulas are kind of connected to each other, where they're all based on the idea of base and height of the shape. So I wrote it as length times width just to stay consistent with the formula sheet, but you can think of it also as base times height. So for this rectangle, we know the length and the width. That information is already on the page for us. So the length is 10 feet. And the width is 6 feet. 10 feet times 6 feet is 60 square feet. All right, so we calculated the area of our individual shapes. Now we're going to combine those to get the total area of our compound figure. When we add 6 square feet and 60 square feet, we get a total area of 66 square feet. And that would be our final answer for area of this compound figure. So for this example, for perimeter, we checked to see if we had any missing sides. We did not. So we just went right ahead and we added up all the sides to get the perimeter. And then for area, we split the shape up into simpler shapes. And then we calculated the area of each shape individually. For our triangle, we needed to fill in the missing information. So we know for a triangle, we need the base and the height. So we had to figure out what the base and the height were before we calculated our area. And then for a rectangle, it was just length times width. And then our final step for area was to add the individual areas together to get the total of 66 square feet. All right. So the last thing we're going to work on in this lesson is we're going to do 3 word problems together. All of these problems that we're working on together are similar to questions that I put into this week's assignment. So if you had already started looking at those assignments, these problems that we're doing now together should hopefully seem a little bit familiar. All right, so practice problem number 1. Rusty needs to order enough wood to fence in the community garden grounds, which are in the shape of a regular pentagon, a pentagon with 5 congruent sides. If the fencing costs $15 per foot, how much will it cost to fence in the community garden? So we've got a picture here. Got a picture here for this shape. Sorry, I just had to change location. Picture here of this garden. It's a 5-sided shape. It's a regular pentagon. So that means it's a 5-sided shape where every side is the same. Another word for that is congruent. So we have 5 congruent or equal sides. Fencing costs $15 per foot. How much will it cost to fence in the community garden? So we need to know how much fencing do we need, right? For our project, if we want to fence in this garden, we need to know how much fencing do we need. So fencing to go all the way around the garden is going to be the perimeter, right? The total distance around the shape, the total amount of fencing we need is the perimeter. If each side is 20 feet, and we've got 5 equal sides, that's going to be a total perimeter of 100 feet. So all the way around this shape, all the way around this garden is 100 feet. So we'll need 100 feet of fencing. So we need 100 feet of fencing, and the fencing is $15 per foot. So our total cost will be the fencing, the amount of fencing we need, 100 feet, times the cost per foot, so $15 per foot. $15 per foot. And 100 times 15 is 1,500. So it'll cost $1,500 to fence in this garden. And that's our final answer. All right, let's take a look at the second problem. So find the missing value in the given trapezoid if its area is 45 square centimeters. 45 square centimeters is the area. So they tell us the area. And then if we look at the picture, we've got some of the information filled in for us. So we know the measurement of the top and the bottom here. And then we've got this missing value. So X is standing in for this missing value. X is the missing value. So what I'm going to do is I'm going to start by thinking about the information they gave me. Area is 45 square centimeters. Well, we're talking about area of a trapezoid. So right away, I'm going to go ahead, I'm going to take a look at my formula sheet, and I'm going to write down the formula for area of a trapezoid. So it's a half times the height times the sum of the two bases. So base 1 plus base 2. I got my formula written down. I'm going to go ahead and I'm going to start filling in the info that I know. So I know the area is 45. So I'm going to replace that A with a 45. So I know what it is. Half stays the same. And then what about the height? Do I know what the height is? Well, actually, I don't. The height is the missing piece of information, right? The height is this thing they've called X. It's a straight line going from the bottom to the top of the trapezoid. It's a straight line that goes from base 1 to base 2. So I do not know that information. That's actually the information that I am looking for. So I'm going to actually put that at the end, because I don't know what that is. I'm going to put all the information I do know up front here. The reason I can do that, the reason I can rearrange this a little bit, is because it's all multiplication, right? So it's saying a half times the height times the stuff in the parentheses. With multiplication, you can change the order around, but you still get the same answer. So I can do that when I'm writing out my work here. So I've got a half times the stuff in the parentheses times the height. Still means the same thing. Okay, so then speaking of stuff inside the parentheses, what should go inside the parentheses? Well, it should be base 1 plus base 2. That's going to be the top and the bottom of the trapezoid, the two parallel sides. So and it doesn't really matter which one you say is base 1 or which one you say is base 2, because they're just going to get added together anyway. So we'll say 10 centimeters plus 8 centimeters. Okay, so I've got all of the information I know filled into this formula here. I don't know what the height is, but there is some work that I can still do without knowing what that height is. So what I'm going to do now is I'm going to simplify this equation, simplify this formula as much as I can without knowing the height. So I might not know what the height is, but I can definitely add what's in the parentheses, right? I can find the sum of the two bases. So keeping everything else the same, right? Just taking it one step at a time. I'm going to find that sum. So 10 plus 18. 10 plus 8, which gives you a sum of 18. 10 plus 8 is 18. So now I've got 45 equals a half times 18 times the height. I'm going to go over here and just make a little note that X, for this trapezoid, X is really the height of the trapezoid. Okay, so I still don't know what H is, but I can figure out what half of 18 is, right? A half of 18 times the height. So 45 equals a half of 18, which is 9. Half of 18 is 9 times the height. So now I've gotten to this much simpler statement, which says that 45 is equal to 9 times the height. So So I'm really looking for whatever number it is that makes this statement make sense. So what number makes this true? Well, you might know that off the top of your head. You might know that 9 times 5 is 45. Hopefully you do know that, because hopefully you know your times tables really well. But maybe if these were bigger numbers or if there were some decimals in there, you might not know off the top of your head. So if you don't know off the top of your head, the way we can figure that out is with a little division, right? So if 9 times something is 45, another way we can say that is 45 divided by 9 equals that something. And 45 divided by 9 equals 5. So that missing height, that missing measurement is 5 centimeters. Not 5 centimeters squared, right? It's just a measurement of length here, that side. We're not talking about the space inside of the shape, just the length on one side. So it's 5 centimeters. And that is our final answer. So for this problem was kind of working backwards, right? On the previous slides, our goal was to calculate area, but for this one, we started out by knowing the area and we were kind of walking backwards to figure out the missing heights. So I started out by writing out the formula for area of a trapezoid. I filled in all of the information that I knew. I worked to simplify that information as much as possible. And that finally got me to that last step here where I found the missing height, the missing piece. All right, let's go on to the final problem here. We're almost done. If you've made it this far, congratulations, you've done a lot of work. So last problem, number 3, the following shape is formed by attaching a square whose sides measure 6 meters to a semicircle whose diameter is 6 meters. What is the perimeter of the shape? Round your answer to the nearest tenth. Okay, so we know we've got a square here. Each side of the square is 6 meters, and that's attached to a semicircle. So that means a half of a circle whose diameter is 6 meters. So thinking back to last week with that circle vocabulary that we worked on. We want to know the perimeter of the shape, so the distance all the way around the outside, of this shape. Well, with the 3 straight sides here, that's going to be pretty easy. We know that this is a square. Each side is going to be the same, so each side is going to be 6 meters. So it would be 6 meters plus 6 meters plus 6 meters. I'm going to fill in that info here. Change colors. So 6 and 6 and 6 on each side of that square. We don't care about the 4th side of the square because it's on the inside of the shape, right? Perimeter is just about the outside. Now, we also, to calculate the total distance around the shape, we also are going to need to know the length of this curved side. So when we're talking about the distance around the outside of a circle, right, that word is circumference, and we have a formula for that. We know that the distance around the outside of a circle, the circumference, is equal to pi times the diameter. That comes from our formula sheet. Pi times the diameter of the circle. So this isn't a circle, it's a semicircle. That just means half a circle. So what I'm going to do is I'm going to start by pretending this is just a whole circle. So pretending I was calculating the distance around just a regular old circle, kind of imagining this is a circle. And then when I've done that, I'll just cut the measurement in half to get the distance around half of the circle. So, back to my pen here. All right, so pi, hopefully you remember that from last week, but if you don't, it's also written on your formula sheet. Pi is approximately 3.14. It's always the same. So pi is just this special number, 3.14. And then we know the diameter of the circle is 6 meters. So we know that because it says a semicircle whose diameter is 6 meters. We could actually also tell that just from looking at the picture. So we can see here that this measurement across the shape is 6 meters. That means the measure across this circle right here, across the semicircle, the diameter is going to be 6 meters. So the diameter of the circle is 6 meters. I'm going to go ahead and do that multiplication. Where's my calculator? Oh, no. Oh, here it is. Okay. So 3.14 times 6 meters gives me the total circumference around our imaginary circle, right? Our imaginary full circle. The total distance around it is 18.84. 18.84 meters. But then since we're talking about a semicircle or a half circle, I'm going to take that distance and cut it in half. So for the semicircle, we want half of the distance around the whole circle. 18.84 meters cut in half, so divided by 2. And that gives us 9.42 meters. So we finally got the length of this curved side here. So the distance from here to here is 9.42 meters. Okay, so now to find the perimeter, you just add up all of those sides. We already know the 3 straight sides. So we've got 6 plus 6 plus 6, or you could do 3 times 6 since they're all the same. Plus that curved side of 9.42. And that gives us a total of, let's make sure I'm adding everything up correctly here, a total of 27.42 meters. So is that our final answer? Well, no. Our final answer is not 27.42 meters because the directions in the question say round your answer to the nearest tenth. That's what the question tells us to do. So that means right now this number is going out to the hundredths place, right? We've got our decimal point, and then we've got the tenths place, and then the hundredths place. So when it says round to the nearest tenth, that means we want our number to stop at the tenths place. We don't care really about any information past that. So the 4 is in the tenths place. I take a look at the digit to the right, and it's a 2. That 2 tells you to round down. So 27.42, we're going to go ahead and just round that down to 27.4. .4 meters. Now you might have been thinking 27.40, like 27.40. It's another way to think of it. So you can think of it as, right, 27.42 would round down to 27.40. That thinking is absolutely correct. However, since we're talking about decimals here, in a decimal, the 0 at the end is called like a trailing 0, and it doesn't actually affect the value of our number at all. So we could get rid of that 0. It would not change the value. And since the question says round your answer to the nearest tenth, it really means technically if you're being like totally correct, your answer should stop in the 10th place. So if you said 27.40, technically you're still correct, but if you want to be super correct, super following the rules here, it would be 27.4. And certainly if this was a multiple choice question, you would only see answers going out to that 10th place. So you would not see 27.40 as a possible answer. You would see 27.4. All right, everybody. Well, that is all I have for you in this lesson today. So remember that the problems that we covered, all of these different examples, are going to be really similar to all of the assignments that I've posted for this week. So all of the assignments posted on Google Classroom between June 1st and June 5th, they're all based on this lesson. So the assignments that you should be working to complete is the problem of the day that I posted. I actually posted it on Monday. So it says problem of the day for June 1st. We've got worksheet Wednesday for June 3rd. And then we've got the problem of the day for June 5th. So each of those assignments contain problems that are very similar to what we just worked on together. As you work on the assignments, make sure you got your pen and paper out in front of you. Don't try to do it all in your head. Probably going to be really helpful to have a calculator. So either on your phone or if you got another calculator, you can have that out. You might find it helpful to have your notes in front of you. Hopefully you've got some notes to look at from last week's lesson and this week's lesson. And then also your formula sheet will be really helpful. Next week, we're going to be moving on to a different topic. We're going to be talking a little bit about functions and patterns. I'm really excited to talk about that. It's one of my favorite things to talk about for GED preparation. It's also a really important topic on the test. So I hope you all have had a great week. I hope you have a great weekend. Stay safe, stay healthy, and I will talk to you next week. Take care.